in this last section of polynomials and factoring, in this particular chapter, we're going to look at factoring using the distributive property. Okay, so again, it's just really a lot of work with taking out greatest common factors. So obviously in our prerequisite skills section here, we're going to talk about, again, the process we take of finding a greatest common factor. Okay, so in numbers 1 through 3, that's exactly what we're doing. So for number 1, I'm just going to go ahead and write down all the factors of 9, right? So again, obviously you got 1 times 9, okay, you got 3 times 3, and that seems to be the list that we can make, right? There's really nothing else we can, two other whole numbers that we can multiply by each other to get 9, okay? And then we have 12, right? So obviously we have 1 and 12, that doesn't really help us, but then we have maybe 2 times 6 and then 3 times 4, okay? So what we get here is, what we see is that 3 is the largest factor that each of these have in common. So therefore our answer here is actually 3, okay? So let's look at number 2. Okay, these numbers might be slightly different, right? So I have 51 and 85. So definitely more difficult here to find what the greatest common factor is. Okay, and so we'll take 51. Okay, and obviously you have 1 times 51, right? Again, that doesn't really help you to find the greatest common factor, but again, those are factors of 51. Okay, I know that 51 is not going to be divisible by 2. Okay, and so I now have to check and see if it's going to be divisible by 3, right? So 3 times what number might give me 51? So I'm just going to go ahead on the side here and take 51 divided by 3, excuse me. So 3 will go into 5. I know it's going to go into 5 one time. Okay, that, 1 times 3 is 3, so I'll subtract. And then I know that 3 goes into 21 7 times exactly, right? So 3 times 17 are another pair of factors that multiply together to give us 51. Okay, and so I can sort of keep thinking through this, right? So 4 times a number, that would have to be even, so that's not going to work. Okay, 5, well, if 5 times a number, any number would have to end in 5 or 0, so I know that 5 is not going to work. 6 is not going to work because, again, this number is not even, right? So now I can maybe check 7. Okay, 7, well, I know that 7 times 7 is 49, so, and then 7 times 8 is 56, so that's not going to work. Okay, I can look at maybe 8, and I know that 8 doesn't multiply perfectly into 51. I can look at maybe 9, I know that 9 doesn't work, or 10 doesn't work, 11 doesn't work, 12 doesn't work. I'm kind of running out of numbers quickly, so I think I'm going to stop there. And then afterwards, I obviously have to take a look at 85 now, right? So, okay, again, 1 and 85, that's not really helpful, but I know that 2 will not work, so let's check 3. Right, so 85 divided by 3. I know that 3 is going to go in here twice for 6. I'll subtract here to get 25. Right? When I bring one down, I know that 3 does not go perfectly into 25. I know it goes 8 times, but then we're going to get a decimal, right? So that won't help us either. Okay, I know that 4 won't work because 85 is not an even number. Let's try 5, right? So 5 should actually work here. So I know that 5 goes into 85. Well, 5 goes into 8 one time for 5, right? And then I'll subtract to get 3. Bring down. I know that 5 goes into 35 7 times. Okay, so it looks like 5 times 17 is also going to give us another option here. Okay, we can actually stop now because we see that these two numbers are actually going to match. Right? I know that 51 is not going to be a factor of 85, so that's not going to be a possibility. So our magic number here actually turns out to be 17. Okay, and we'll just get a little bit more practice here, I suppose. So we'll look for the factors of 30, 1 times 30, 2 times 15, 3 times 10. Let's see if any others work. 5 times 6 will work. I think that's our list. Okay, let's maybe look at some factors of 45. Right, so 45 would be 1 times 45. Let's see, 2 is not going to work. 3 times 15 would work. 4 won't work because 45 is not even. 5 times 9 is 45. Let's see, 6, 7, nope. 8, 9 won't work. 10 won't work. This seems to be a pretty solid number here, or a pretty good list of factors, and let's look at 105. Okay, so 105 might be slightly more difficult, but obviously 1 and 105. kind of see if I can keep thinking through here. 2 won't work. 3 might work. Let's take 105 divided by 3 and see what we get. 3 goes into 10 3 times. For 9, I can subtract here to get 15, right? So this is 3 goes into 15 3 times, right? So 3 times 33 is, that doesn't make sense. Hold on, looks like I made a small mistake here. 3 times 33 is going to give me 99. So let's just take a look at this again, okay? So again, 3 goes into 10 3 times, or 9, right? Subtract to get 15, right? 3 goes into 15 5 times. That seems to make a little bit more sense, okay? So now 5, okay, so again, 3 times 35 evidently is going to give us 105, okay? And so there we have it. 3 times 35 will give us this magic number of 105. Let's maybe keep going. We know this has to be divisible by 5, right? So I'll take 105 divided by 5. Okay, 5 goes into 10 twice for 10, right? And then 5 goes into 5, so this will be 21 times. So 5 times 21. Let's see. Let's try maybe, let's try like 15. Let's see if 15 will actually work. Okay, so we'll see how many times 15 goes into 105. Okay, well this one's kind of tough to do, but let's see. I know that 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45, 15 times 4 is 60, 15 times 5 is 75, 15 times 6 is 90, 15 and 7 is actually going to work here. Let's just make sure and multiply this out. 15 times 7, I get 35 and 105, right? So 15 times 7, or 7 times 15. But long story short, we see that our greatest common factor here is actually going to be 15. Okay, I know that process is sort of long, but we definitely have to be able to find the greatest common factor without a calculator here. Okay, and then finally here, let's just do some quick distributive property review. Okay, I know this warm-up is sort of long, but that's okay. All right, so 3x times 4x, remember, we'll multiply the coefficients together first to get 12, then x times x will give us x squared. Okay, then we take the 3x times the positive 9 here, and that will give us a positive. 9 times 3 is 27, and then I'll attach the x, and this is going to be my final answer. Pretty easy, okay? And then finally, again, we'll distribute the negative 3 this time, so negative 3 times 2 will give us negative 6, and then the x to the third we must attach onto there. And then finally, we have negative 3 times positive 5 here is going to give us a negative 15, and that will be our very final answer. Okay, so now that we've looked at some prerequisite skills, we should be ready to practice factoring using the distributive property.